So today we're wrapping up chapter 11 in sections 11.6 and 7. We are highlighting the important parts of this section, these two sections, and really just the whole concept is, how do you know if figures are similar? Sometimes you're told that they're similar and we'll look at their ratios. Other times we're trying to prove that they are similar, yes or no, okay? And that's what we see in example 1. Similar figures have the same ratio of x and y values when it comes to ordered pairs. So if we have a graph like you see here, you can just turn in your books to page 492. You don't have to draw that graph. Just turn in your books to page 492. What we're going to do is we're going to pull out these ordered pairs, points A, B, and C, and we're going to try to see if there's a connection between their x and y values, basically an operation that's getting us from the A values to the B values, or I'm sorry, from one figure to the next is what I was trying to say. All right, and we'll talk about the sequence in just a sec. Are you guys there on page 492? Okay. All right, we need to talk for just a minute. Are you guys there? We need to talk for a minute. Do I have your attention? Okay, it's not a long lesson. I need your attention up here, guys. All right. About corresponding points, okay? The word corresponding. What that means is we have to figure out 2 points that basically occur in the same sequence on a figure. What do I mean by sequence? You're always going to have in your directions, and you see it right here at the top of example 1, determine whether triangle, and it has a triangle symbol, I'm writing this on the top right corner, ABC is similar to triangle JKL. And this sequence is very important because the first angle that is mentioned in each sequence is those are coordinating points, okay? So points A and point J, those are corresponding, all right? Meaning that if these figures are similar, there should be a clear connection basically on, am I multiplying by a certain number or dividing by a certain number to get from my A value to my J value. All right, that'll make more sense in just a minute. So when I'm setting it up here in my ordered pairs, I'm trying to see, is something happening to my X, Y values in point A? I'm just going to change the color real quick. In point A, is something happening to, and I'm going to kind of space it out a little bit to get to my point J over here, ordered pair. All right, because A and J are corresponding. Oh, I forgot my little prime symbol. All right. Okay, so for B, I'm looking for similar patterns. But let's go back to A. Can anybody tell me, look at the graph, what is the ordered pair for point A? What's the ordered pair for point A? It is 0, 3. Okay? And now let's go over here to point J. Remember, there should be a clear connection between A and J, and the same thing with the other corresponding points. But let's just start with A and J. What is the ordered pair that matches J? 0, 6. Okay. All right. So what could I do? Well, 0 is not going to really help me much. How could I get from a 3, multiplication or division, how could I get from a 3 to a 6?
Multiply by 2.
Multiply by 2. And would you agree 0 times 2 is 0 also? Okay. So for point A, I'm going to say, and guys, this middle step is not one that you would have to show on a test, but what I'm doing here is showing you kind of the why behind why this is actually a similar figure, and it'll make more sense once we do them all. Okay, so to get from A to J, I multiplied X and Y by 2. Okay, so I'm looking for that pattern for the other ordered pairs. If it's there, then this figure is similar. If it's not there, let's say for point B I had to multiply by 3, then it's not similar. Okay? So what's the ordered pair for B?
3, 3.
Yeah? And what's the ordered pair for C? The original one.
Oh, 0, 0. 0.
Close. 3, 0. Okay? And now let's come over here to their corresponding points. According to the sequence, which point corresponds with B? K, because it also comes second. What is the ordered pair that matches K?
6, 6.
6, 6. And what about L? What about L? 6, 0. Okay, so everybody's clear on where I'm getting these ordered pairs from.
Yes.
I'm looking at the points on the graph and writing their ordered pairs. Well, again, if I'm testing to see if they're similar, I already have a pattern that's been established by point A. So I just need to test it for the other points, okay? So again, this is why, the showing work part isn't necessarily, I'm not going to take off if you don't show it, because now that we're looking for a pattern, can we just mental math? What's 3 times 2? 6. Okay, so my pattern is still checking out. But again, if even one ordered pair falls out of that pattern, it's not similar. So what about my y values? Can I multiply by 2?
Yes.
Yeah. What about point C between my x values?
Yes.
3 times 2 is 6? Is 0 times 2 0?
Yes.
Okay, so because from triangle ABC to JKL, there is a similar pattern happening that I'm multiplying by 2, I will say that yes, this is a similar figure, and more specifically, it is a dilation. And what is my scale factor?
2.
And remember, the variable that we use for scale factor
K.
is K. Okay, so just for us to identify this is a dilation, and that's what it's going to be. Okay, it's not going to be any of the other transformations, because similar figures are one is small and one is big. So we are looking for a dilation scale factor. If there is not a consistent scale factor, it's not similar. Are you with me? You get it? Okay, so that's example 1. The next example, this should say example 2. Okay, example 2. So sorry, it's because it's 11.6 and 7 combined, and I just forgot to switch that. Okay, so now we're taking that whole concept of similar figures and we're applying it to now ratios, and we'll talk about perimeter versus area. So for perimeters, all right, so here's the key word that you're going to want to look for. When it calls for perimeter, okay, we have to be comparing the same side lengths. Basically, you can't compare one figure is the width and the other one is the length. You have to be comparing, we'll call it corresponding sides, meaning the same side of each figure. So you can see on the red, from the red to the blue, we have values both on that left side of the figure, same location. You guys see that up on the screen? All right, so here's what they want me to do. They're telling me that it's similar right off the bat. So because it's similar, we can use ratios to establish values and then ultimately to solve for unknown side lengths, which you're going to see in just a minute. But right now, we're just practicing writing the value of a ratio. All right? Now, the red to blue part is important because that tells me the order. How do I know if it's 4/6 or 6/4? All right? So that red to blue tells me which value comes first. 4 to 6 would be written as a ratio, and can this be reduced?
No. Yes. I'm sorry.
And then you box it in. Okay? That is all you have to do. You have a section like this on your classwork. Okay? All right, so that's your perimeter. And again, you might think, okay, well, what's the point of that? That's like so easy. In a couple slides, we're going to use that value of the ratio to actually solve for an unknown side. So that's where we're going with it. All right, so now the only difference between the last slide and this slide is now I'm comparing their areas. Now I'm comparing the area. Find the value of the ratio. Again, okay, here's what's important from red to blue of the similar triangles, okay? Well, perimeter-wise, I would just put it into a fraction and reduce it. Here's the difference with area. I still put it into a fraction. 6/10. Can that be reduced? Yes. I still reduce it. 3/5. That's the perimeter. That's what I just did. But now to make it the area, I must square the fraction. All right? And when I square a fraction, that means I have to square the numerator and denominator. What is 3 squared? 9. What is 5 squared? 25. So on this section, guys, they're going to ask you for both. Well, the perimeter, you just reduce it. That's perimeter, locks it in. For the area, you just square the numerator and denominator. And then that would be it. Okay, next example. Sorry, my example numbers are jumping around a little bit. All right, just kind of ignore those. All right, we'll just focus on the context of the slide. All right, here's what this one is saying. And this is what I was just a minute ago telling you, is now we're going to use the value, the ratio values, okay? And these figures are similar figures. I guess the instructions may have said that, but yes, they are similar figures, so we can use their ratios to find an unknown side length. And here's how we do it. All right? We can put 8 to 5 into a fraction. We know that the first number in our ratio is the numerator and then the denominator. Okay, so one, and I guess I could call it a complaint about your book because this was actually copied out of the homework pages. They don't have red to blue like they did in the example. So it's like you kind of look at it at first, you're like, okay, well, which one's the first one? So when it is not clear, we are going to go left to right. Okay, and that's what they did. That's how they came up with the answer. I kind of feel like a mind reader here because I feel like there should be a difference, and that's what you would see on a quiz or a test. I'll either make it a dotted line, but I'll tell you we're going solid to the dotted figure, all right? So x, or the first figure to the second figure, would be x over 16. And what we've done here is we've now created a proportion. Remember, proportions must be comparing kind of like corresponding side lengths on both sides of the proportion, meaning the same side on each figure. And now I can use one of my strategies for solving a proportion, cross products or equivalent ratios to solve. We're going to use cross products. All right, you guys remember 5 times x is 5x, and 16 times 8 is
128.
Yes, 128. It's not a race, guys, don't worry. There's no prize. Okay, how do I solve for x? How do I solve for x, Isaiah?
Since you're doing multiplication, you do 5x divided by 5.
Very good. Divide by 5 both sides. And x equals
25.6.
25.6. X equals 25.6. And again, there's no like label or anything, but that's okay. All right, x equals 25.6. So I can use their ratio values to find an unknown side length. All right, and that's what we're going to do now on the last slide. Okay, all right, what is the image on top? What do you see there? Swimming pool. All right, what is the image on the bottom?
Tennis.
No, look up there. You're close. Look up in the words. It's a volleyball court. I know it looks really small in the slide. Okay, guys, be quiet.
It looks like a ping pong table.
Well, yeah, it's very similar, but the instructions say that it is a volleyball court. Okay, so here's what we're looking at. Guys, pay attention. Okay, they're saying that these shapes are similar. We obviously have a lot more information on the volleyball court. Okay, but the first thing we need to be able to do is identify what information is even here in the first place. Okay, so 18 yards, would that be the width of the swimming pool or the length? It is the width. And then 10 yards, what do you think that is? The width also. So corresponding side lengths. Both of them are the widths. That's important. All right, so what they want me to do is solve for the perimeter and area of the pool. So let's start with perimeter. We need to set up a proportion. Sorry about that. Okay, so finding the perimeter of the pool, we must set up a proportion. All right, well, let's set up a ratio of, we know both of them, and that would be the widths of each figure. We are given a value of the width of each figure. What is the width of the swimming pool? No, swimming pool. 18. What is the width of the volleyball court? 10. Okay. If I'm trying to solve for the perimeter of the pool, again, we just went pool over volleyball court on the first ratio, so it has to match up on the other side. Do I know the perimeter of the pool?
No.
Okay, so I'm going to put a P. Since I'm solving for perimeter, which value down here in the volleyball court do you think is going to apply to this?
60.
60, right? Because I need to compare perimeters top and bottom, okay? So here we go, P over 60. Does everybody understand why we use 60?
Yes.
On both sides of the proportion, I'm comparing the pool over the volleyball court. That's very important that you are comparing. Same thing, both sides. Now you can do cross products to solve. You could even do equivalent ratios, either one. But cross products to solve, 10P equals, what is that, 1,080? 280. No, it's 1,080. Okay. Divide both sides by 10. And the perimeter, this is the whole perimeter, the whole distance around this pool is 108. And here's where the label is very important. We found perimeter, so it's yards. 108 yards. All right, now area. Again, setting up the ratios, the proportions, that's a really important part. Okay, so setting up the area. All right, again, we need one side of the proportion to be both values that we know. We can still use the same ratio, 18 over 10. Okay, 18 over 10 is fine. Equals, now I'm solving for the area of the pool over what is the area of the volleyball court? 200.
400.
No, it is 200. It is 200. The unit is squared, but it's already been evaluated. Miles, it's already been evaluated. 200 is the answer. Okay? All right, now hold on though. These two ratios, how they're written now, I just wrote the ratio for the perimeter. How could I write 18 over 10 as the area? Do you remember what we did to that ratio in that slide? I squared it. Okay? So until you square it, guys, that's the perimeter ratio. You have to square it to make it the area ratio. All right, now, calculators are allowed in this chapter. I'm not going to take them away from you. You could do this. Actually, much easier if you reduce the fraction first. 18 over 10 reduces to what?
9 over 5.
9 over 5. Can you square 9? What is 9 squared?
81. Oh, wait,
Yeah,
squared.
9 squared is 81. And what is 5 squared?
25.
Okay, and that's what it is, 81 over 25. Now, if you put 18 over 10 squared into your calculator, it's going to automatically reduce it for you. Okay, but that's where that answer comes from. Equals A over 200. Now you can do cross products Okay, so cross products, 200 times 81 to solve, and you get 25A equals, that's going to be a pretty big number. What is it, 16,200? Okay, I couldn't remember the exact.
What did you get?
Is it 800? I thought it was. Wait, hold on. Let me just multiply it.
I did 200 times 81.
Yeah, 200 times 81.
I did 18.
Yeah, 16.
Yeah, 16,200. Okay, 16,200. Divide both sides by 25.
360.
Okay, and the area equals 648. What's my label?
Square unit.
Hold up.
Square yards or yards with an exponent of 2.
Oh.
Okay, guys, so if you understand that, that is everything you need to know for these sections.